North Road made this.
Hello, I'm David Okeode, principal instructor at Kavis Cloud, 4 times Microsoft MVP, and author of multiple books on cloud security. I would like to speak with you about our courses at Kavis Cloud. First, we are cloud security focused. We maintain an unbiased stance towards vendors, and we cut through all the typical marketing jargon in many trainings out there. We help you to understand things as they really are. The second thing that's unique about our courses is that we are multi-cloud focused. Our multi-cloud security courses covers the top 3 public cloud platforms out there: AWS, Azure, and GCP. Our instructors are not just trainers, they are seasoned professionals with real-world experience. The third reason is that our training modules are designed to provide practical hands-on experience. Our courses are packed full of hands-on labs that you find engaging and interesting. And finally, our prices are the best out there. I encourage you to check out our upcoming courses on our website and also testimonials from our students. See you soon at www.kaviscloud.com. Hello everyone. Hello and welcome to today's session on Microsoft Azure Studies or Microsoft Azure Security Studies. Let's get rid of that and let's share the screen. So welcome. Thanks very much for joining me again today. So I'm glad that you're here. So we're going to pick things up from where we stopped last time. Just talking about just general information around securing the Azure cloud platform. So I'm sharing my screen now. Yeah, there we go. Okay. So last time, if you remember correctly, we focused on tokens and we talked about tokens in general. We talked about authentication to Azure. We talked about how our Entra ID supports different authentication flows. So last week, for example, I emphasized we have the device code flow, we have the authentication transfer flow. We have many other flows like that exist. And I also mentioned, and I showed you examples last time, that depending on the type of flow that is implemented, that's going to determine the types of tokens that will be involved. For example, if you're doing the client credential flow, which is what is used for a daemon application, that only uses an access token. A refresh token is not used. But whenever you have a situation where you have an application and the application needs to access an API on behalf of the user, then you have the access token and refresh token present. And if you remember correctly, what we also shared last week, so we also mentioned like some of the use cases around like the access token. So that's what's used to access APIs. And we said by default that as a lifetime. Said with the refresh token, the refresh token. Oh, let's do that again. So the refresh token was said that is useful. Okay, let's do that again. The refresh token that is useful. Oh, just to confirm, are you able to hear me? Because I'm getting like some error messages in the stream. If you can just confirm in the chat window whether you're able to hear me and see my screen clearly, that will be helpful because I'm getting some error messages on the stream here. Anyways, so while you confirm that, so we said refresh token can be used to get a new access token when that 1 hour lifetime has expired. So it gets a new access token. We said by default that has a lifetime of 90 days. The exception to that is if you're working with a single page application. Working with a single page application, the lifetime of the refresh token is not 90 days. Believe that is 24 hours. So for single page applications, that is 24 hours. Okay, so what I'm going to, so that was what we discussed last week, and I talked about how that ties into conditional access, how Microsoft are giving us options to protect the flows that could be exploited, like device code flow, authentication transfer flow. So today we're going to look at something in relation to non-human identities in Entra ID, which we're going to look at workload identity federation. We're going to look at workload identity federation. But before we get into that, let's just give a quick primer on application or non-human authentication in Entra ID or in Azure. So let's go ahead and let's bring that up very quickly. So non-human identity authentication in Azure, what does that look like? So there are different options that Microsoft offers to us. So let's go have a quick look at some of this. So apologies, I'm trying to bring up like the slides now. And okay, slide is now up now. So let's by the way, if you put in the chat window where you're joining, that'll be that window and we can see. So just bringing up the slides and let's come on. Okay, here we go. Okay, so let's look at some of this stuff. So Azure supports different type of authentication when it comes to non-human identity. So let's talk about what some of this looks like. So let's bring some of these up very quickly. And apologies, my system is just a little bit slower. That's better. That's better. That's better. Okay, let's get to this. So let's share this. So when it comes to application or non-human identities authenticating to Azure services. So that could be multiple scenarios. That could be you have a script that's running and performing some operations against your Azure environment. That could be, in the case of the example that we have on the screen, that could be an application. And the application needs to be able to access objects in an Azure service like Azure Key Vault in this case. That could be an application that needs to access data in Azure database, Azure SQL database, or in in an Azure storage account in a blob container. There are different options that we have to make authentication work for non-human identities. One of the options is to use a service principal. Very straightforward. Many of you are familiar with that. We go to Entra ID, and in Entra ID, we do an application registration. When we do an application registration, that's going to create two objects, right? It's going to create a service principal and it's going to create an application object. So you can think of the application object as a globally unique ID that identifies this service that you just registered. So that is unique across all of Entra ID. You can think of the service principal as a locally unique ID for that application that you just registered. So this is locally unique. So this is what the application uses if it wants to perform an operation within its home tenant. But if this same application needs access to perform operations in external Entra ID tenants, then you need to go create a service principal object in those external tenants. It's sort of like similar to what we do with user identities, right? In Entra ID, the way user identity works is every user is part of a home tenant. So let's say we have a home tenant here for a company called Caris, and we have another company here, which I'll just call Contoso. We have a user called Brenda in this tenant. The user called Brenda needs to access resources in the Contoso directory. We can invite that user to the Contoso tenant, and once we've invited them, then we can grant them permission to resources in the Contoso tenant. It's the same thing here with application identity. Essentially, that's a similar concept to what we're doing here. It has every application that you register as an object in its own tenant, but if it needs to perform operation in external Entra ID tenants, then you need to create a service principal object for it there also. So anyways, here we have an application registered, we have a service principal, and once we've done that, there are different ways to authenticate with that service principal. The third way is what I'll focus on today, which is workload identity, federation, or federated credential. But we can use a secret key. We can use a certificate. But we can also use a federated credential. And when we talk about how secure or the level of security that we want to go for, using a key is the least secure option. Why? Because it can be easily exposed. So you're using that in your application, in your script. If somebody gets a hold of the script, they can see the service principal ID, they can see the key, and they can use that to authenticate. So then you have to take on the extra management overhead of rotating the key. So that's considered to be the least secure. The second option is to use a certificate to authenticate. Using a certificate to authenticate is considered to be more secure than using a key, because certificates are generally stronger. You have a private public key, so you upload the publicly, and then you can keep the private key and use that to authenticate. So that's considered to be more secure, but it still falls into the other issue of you have to rotate it, you have to protect it so that it doesn't get exposed or leaked. And then the third option that we have is to use a federated credential, which is considered to be more secure, especially if the service that needs access is outside Azure. You have a service running on GCP, you have a service running on AWS, you have a service running on premises, and it needs to be able to authenticate to Entra ID to access services in Azure like Azure Key Vault. Using a federated credential is considered to be the most secure out of those three options. So anyways, in this case, we're using a key. If I have a key, I can then give the service principal ID. I can give it permission to any resource. So I'm using Azure Key Vault as an example, but this could be anything. This could be Azure Blob Storage. This could be Azure SQL Database. I grant the necessary permission to the ID, and then I need to put that in my code or in my script or in my application. I put the ID and the key there, and then my application can use that to authenticate to Entra ID. It's going to obtain an access token like we talked about last week, and then it can use the access token to call whatever service or whatever API that it needs to call in Azure. So that's the general flow of this. As I mentioned to you earlier, if you're using the key option or the certificate option, that's considered to be less secure. Why are they less secure? The reason why they are less secure is because if this falls into the wrong hands, if somebody has permission to review your code and they're able to see the ID and the key there, they can use the ID and key to authenticate to Entra ID, get an access token. Now, remember that we talked about that you can use conditional access now with, there may be some level of protection that you can do. But if they're able to bypass that, they can essentially get an access token and then use that access token to make whatever call that it needs to make, right? Another option when it comes to granting permissions to non-human identities in accessing services and stuff in Azure, authenticating using it through Entra ID, is to use managed identity. Many of you are familiar with managed identity already, but we'll just go through a quick review of that if I show you the demo for today. With managed identity, the credential is managed behind the scene by Microsoft. So we don't need to be exposing, like in the case of service principal, we don't need to be exposing a key, we don't need to be exposing a certificate. But if we're using a key or the certificate, those are going to be managed by Microsoft. Microsoft manages that, so we don't even get to interact with that. So the way that works is my service or my script or my application needs to be running on an Azure service that supports managed identity. David, does all Azure services support managed identity? The answer to that is no. Not all Azure services support managed identities. So the last time I counted, there are 58 services in Azure that supports managed identity. And I'll share the link with you in the chat window. So there are currently 58 services. And in those situations, you also need to be a bit extra careful, because what you may find out is that in some situation, yeah, managed identity is supported technically speaking. However, if you're using the service in a scenario, let's say you're putting it behind a private network, it may not be supported. So you may need to drill down into the documentation to understand whether managed identity is supported for your scenario or not supported. But generally speaking, Microsoft are improving on support for managed identity across more Azure services. So anyways, you enable managed identity for the service that your application is running on. And once you've done that, your application can essentially make a call to a local metadata endpoint, and it can make a call to that to authenticate and get an access token without exposing any credential. As long as your application is running within the service that has the managed identity, you essentially use the identity of the resource to obtain an access token, and then it can use the access token to make whatever call that it needs to make. So hopefully that makes sense to you in terms of service principal and managed identity. Well, managed identity, the downside is it only works if your service, your application, your script is running on a supported Azure service. If your application is not running on the supported Azure service, then you have to go back and use service principal, which means you either have to use the key or the certificate, or you can use the option that I'm going to be talking about today, which is workload identity federation. David, what is workload identity federation? Workload identity federation allows us to do OAuth authorization, OpenID Connect authentication, OAuth authorization without exposing any credential for an external service. So I have a GitHub action workflow, or a GitHub workflow. I have an Azure DevOps pipeline. Both of these are external to Azure. My GitHub workflow needs to deploy software into Azure App Service. My Azure DevOps pipeline needs to create infrastructure in Azure. I want both of these processes and these flows to authenticate without exposing any credential anywhere. How is that possible? It's possible using workload identity federation. Now, workload identity federation, you can enable it in two scenarios. You can enable it for a service principal that we talked about. So when you create your service principal, instead of specifying a key or instead of specifying the certificates, you can specify a federated credential or a federated ID to authenticate. But you can also use workload identity federation not only with service principal, you can also use it with managed identity. So you have your managed identity, especially you have your user assigned managed identity, and you can define and specify your federated ID to use a user assigned managed identity to authenticate. So let's go have a look at this in practice. So first of all, if I head over to the my Azure platform, if I go to my Entra ID tenant, and if I go over to my application registration, so if I go over to app registrations, and I showed this to you last week, but I can go create a new app registration. So I'm going to create a new app registration. So let's say this is for a GitHub workflow. And I'm going to leave, the direct URI. So just going to register this. So I have this GitHub workflow. So traditionally, what I'll then do is I have my client ID, I have my tenant ID, and then I'll go under manage, under certificate and secret. I'll go to add either a secret or a certificate. And then I'll reference those in my GitHub workflow. But you can see here that we have a third option, which is using a federated credential. So if I go to under federated credential, the way that I'll do that is if I go to add a new credential, and I can go specify the scenario that I want to use. So I'll show you that of Kubernetes later, but you can see that I can use that for GitHub Actions, using other issuer. So in this case, if I specify GitHub Actions, deploying resources to Azure, I can specify my GitHub organization name. In this case, I can specify my GitHub organization name, which I have here somewhere. So actually, I'll just specify something. Let's just say David. Okay, I can specify my GitHub repository. So I can say code repo. And I can specify the entity. In this case, let's say it's going to be the main branch of that code repository. And I can give it a name. So my GitHub workflow. And you can see the audience is Azure AD Token Exchange. And if I add that, then within my GitHub workflow, I can go define this client ID. So if I had that, so then what I can do is I can go define this client ID, and I can go define this tenant ID. I don't need to specify any certificate or any secret, as long as the request is coming from this GitHub organization, from this GitHub repo, from this repo branch, that it will be able to automatically obtain an access token without using a secret. So that's how to use that in sort of like a service principal, if you're using that for a service principal. But what about if I'm using that for managed identity? So I'll show you a demonstration of that, and then we can pause for today. So here's the scenario that I want to show you for managed identity. So let's go get this, move this up a bit, and let's get this up a bit. Okay. So let's go. Okay, there we go. So here is the scenario that I have. So what I currently have is I have a key vault, and my key vault has a secret within it. So let me show that to you very quickly. So if I go over to my Azure environment, if I go to on the key vault, I have a key vault here called DO key vault 7478. And within my key vault, if I go to under objects, I have a secret within the key vault. Oh, I don't have one. So let me create one. Let's see. Let's go to create a secret in my key vault. So I'm going to set a secret in my key vault. There we go. So I've set a secret in the key vault. So let's go refresh it. And there we go. So I have a secret here with the name of storage connection string, and I can see the version and I can see the value. So that's what I currently have, is I have a key vault with a secret in it. Now I have a user assigned managed identity. So user assigned managed identity is a managed identity that's not tied to a specific resource. So if I go to under managed identities, I have this user assigned managed identity called DO managed ID 7478. And if I click on it, if I go to the role assignment, what permission does this have? You can see that this managed identity has the key vault secret user role for my key vault resource. So essentially, it has permission to read secrets in that key vault. So which is what I have in the diagram here. So this managed identity, so let me get some text. So managed ID. So this managed identity has permission to read the secret in the key vault. So what I want to do is I want a situation where I can have a pod running in a Kubernetes cluster. And that pod running in a Kubernetes cluster will be able to read these secrets in the key vault without exposing any tokens, without exposing any secret key or any certificate anywhere. So that's what I want to do. And I'll take you through the process of doing this using federated ID, so the workload identity federation. So let's go through the steps together. Number one, let's have a quick look at my AKS cluster. So let's go to Azure CLI. Let's clear the screen and let's have a quick look at my AKS cluster. So the first thing that I'll do is I will check certain property in my AKS cluster. So I have an AKS cluster here. So I want to query, do I have OpenID Connect? So that's what OID stands for, and OpenID Connect issuer configured for this cluster. So that will be the identity provider for my cluster. So that needs to be enabled if I want to use workload identity federation. If I run that, that should be empty, which signifies that I do not currently have an OpenID Connect issuer configured for my AKS cluster. So what I'll do is I'll go to configure that. So I'll go to configure an OpenID Connect issuer, which will be the identity provider for my cluster. So I'll go ahead and I'll do that. So to do that, I've got the command here. So let me magnify this. So I'm going to be using this command here. So AKS update. I'm going to update my cluster and I'm going to enable OpenID Connect issuer. I can also enable workload identity for it if I need to. So I'll just go ahead and I'll copy that and I'll run that. So let's run that. So what that does mainly is it's going to enable an OpenID Connect issuer for my AKS cluster. Once that is done, I'll get the OpenID Connect issuer URL. So this OpenID issuer, so it's going to have a URL, which I'll need for the rest of my configuration. So I'll need to get that URL. So let's go back to this. So this can take a few moments to complete, by the way. So, but it's going to complete soon. So anyways, so it's running. So once that has finished, and I have my OpenID Connect issuer, then the other thing that I'll do is I'll go to create a service account in my Kubernetes cluster. David, what are you doing here? Here is what I'm doing. What I want to do is I'm going to create, so let's get this. Oh, that's too large. So I'm going to create a service account. This service account will be the link between my Kubernetes cluster and this managed identity. So that will be the link between both objects. So I need to create that. So when I create that, I will need to reference my managed identity ID. So that will be the link between both of them. So which is the next thing that I'll do once the issuer has completed. So that's still running. But let me show you what I'll do next once that's done. So once the issuer has been created, I'll create a Kubernetes service account. And what I'll do is I'll call my service account Kubernetes managed identity, which is MID service account. Which namespace will I create the service account? I'll create it in the default namespace. That's fine. And if you have a look at the object definition here, so I'm going to create a service account object, and my service account object has an annotation that has Azure Workload Identity Client ID. So this is specifying to the service account which client ID to use. And in this case, I'll be specifying the ID, the client ID of my managed identity. So if I go over to the Azure platform, here is my managed identity. If I go to the overview, it has a client ID. So that's the client ID right there. It starts with 1cc. I will need to specify that in this for the service account. So again, let's wait for this to finish, which is that's finished now. So let's clear the screen. Let's get the issuer URI in a variable. So, and if I echo that out, yeah, there we go. I've got my issuer URI, so that's good. And the other thing I want to make sure is I also have my managed identity client ID. So let me just echo out this and make sure that I've got that. There we go. So I have my managed identity client ID in a variable. So let's go ahead and connect to our Kubernetes cluster using this command. I'll pull down the credentials. So put down the kubeconfig file. And if I go ahead and I do kubectl get node, so that should help me to confirm that that is good. So I can see information. So that's good. So then what I'll do is I'll go ahead and I'll define the variables for my service account and the service account namespace. So, and I'll use that to create a service account. So let's copy that. And if I go ahead and if I run that, so it says it's created my service account. Let's go ahead and get my service account. So if I do kubectl get service account, and if I specify the name of my service account, which I have in a variable here, so I can go ahead and I can specify that, and I can also specify the namespace. And you can see that my service account exists there. And if I want to get more information about it, so if I go to describe it, And you can see that that's pointing to a managed identity, user assigned managed identity ID. So that's good. And ladies and gentlemen, we're in the right direction. So let's move on. So this is what I currently have. I've got this. So what's the next thing that we do, David? Next thing that I will do is I will create a federated identity credential. A federated identity credential is going to reference quite a few things, right? So let me show that to you in the diagram, what that looks like. So in this case, I'll create a federated ID. So federated ID. And the federated ID, I'm going to be creating that for my managed identity here. So the federated ID is what is going to define which client is allowed to use this managed identity, which external client is allowed to use this managed identity to authenticate. Similar to what I showed you for the service principal earlier, where I specified my GitHub organization, my GitHub repo, and my repo branch. In this case, I'll need to also specify which external resource is allowed to use this identity to authenticate, and I'll define that in the form of a federated ID. Now, I can do that from the UI. Let me show you how to do that from the UI. Here's my managed identity. If I go to under settings, I can see federated credentials there. I can go to federated credentials, and I can go to add a federated credential. In this case, I'm going to be configuring that for other scenarios, so using an external OpenID Connect provider to access Azure resources. So if I specify that option, I'll need to specify my issuer URL, which is where I'll need the information of the OpenID Connect issuer URL, so that there's going to be a trust relationship between both of them. So I need to specify my issuer URL. Then I specify the subject identifier. So that's going to specify, in my case, it has to specify the name of the service account that's allowed to use this ID to authenticate. And then I give it the name. So that's essentially what we're doing. But I'm going to be doing this using the command line instead of using the UI. So in this case, create a federated credential for that managed identity. The issuer, put in the issuer that we created earlier. For the subject name, system service account, so which object can use that ID. So I'm specifying the service account that I created just now. So the service account namespace and the service account. And the audience is Azure AD Token Exchange. So let's go ahead and let's run this to create our federated credential. So let's clear the screen. Oh. And let's run this. So that's created successfully. So let's go ahead and let's verify that it's created successfully in the UI. So what I'm going to do is I'm going to refresh the entire screen. So once it's refreshed, I'll click on my managed identity again. If I go to under federated credential, now I can see my federated credential there. And if I click on it, you can see that it has my Kubernetes cluster, OpenID Connect issuer URL there. It has the namespace that can use that credential. It has the service account that can use that credential. So it has that there, and that looks correct to me. So now we're good, ladies and gentlemen. We're almost done. So this is done. So what that does is that it's going to grant permission to this. It's going to grant permission to this service account, essentially, to use that. So that's what the federated ID is about. So that's what we've just done now. So the final bit of that is, let's go over here. So what I'm going to do is I'm going to deploy a pod to my Kubernetes cluster that can use that service account to authenticate. So this is the final bit. I'm going to go deploy this pod. Now, when I deploy this pod, I'll say to this pod, you need to get this secret in Key Vault. How do you authenticate to get the secret in Key Vault? You're going to be using this service account here, which is linked to this federated ID. At no point in time did I, thanks very much. I can see my says, all right. At no point in time did I expose any secret. At no point in time. So keep that in mind. So no secret is exposed at all. So let's go ahead and let's do this. So thanks very much. So let's go ahead and let's do the final bit and then let's verify. So that's my key vault secret. So it's called storage connection string. So let me set that variable first of all. And if I go ahead and I paste that, and then the other thing that I'll do is I'll go ahead and I'll create my pod. So my pod, I'll call it Kubernetes pod key vault access. Which namespace will it create it into? It's going to create it in the default namespace, which is what that variable points to. Now, this is very, very important if you're going to be doing this. If you're doing this using Kubernetes, you have to set your pod, this label on your pod, the label of Azure Workload Identity Use, and that needs to be set to true. If you do not set this label, this pod will not be able to use workload identity without this label. So this label is very important. So we have this label set. And then we pull down an image from Google Container Registry. And we specify, in this case, some environment variable, which includes the key vault URI to retrieve the secret from and the secret to retrieve from the key vault URI. So let's go ahead and let's copy this and let's run this. And let's verify that that's good. So it says pod created. So let's go check. Is the pod created? Do we have all the information that we need? So what I'll do is I'll say kubectl get pod, and I'll get my pod name, which is this one. So let's copy that and paste this. And it says my pod is running, so we're good. So let's go ahead and let's do some checks to see if everything else is okay. So I want to make sure that my key vault URL and my secrets that the application running in the pod is going to retrieve are correct. So let me go ahead and run that. So check that. So I check the environment variable. Key vault URL is indeed set to my key vault. My storage, my secret name is indeed set to the secret in the key vault. So, and let's go have a look. Key vault. It's my key vault, and my secret in the key vault is this. So we're gonna go have a look. We're gonna test this out, and then we're going to see if our identity is working correctly. So let's run that, and we can see here it says in the logs it successfully got the secret from key vault, and that's the secret value. If I go to my key vault results and I show the secret value, you can see that that's indeed accurate. So that matches with what we have here. So what has happened in this case? In this case, the service account is going to be used to authenticate to the OpenID Connect issuer, which grants a token. The token would then be presented to Entra ID, which exchanges that which validates the token. And then if it's validation, if validation is successful, it then exchanges the token with an access token issued by Entra ID, which the service can then use to make a call to get the secret in Key Vault. So, ladies and gentlemen, that's an example of workload identity. I hope that that's been useful. If you have any questions, I'll be happy to answer your questions. Otherwise, do put, if you have any suggestions on any topic that you'd like me to cover on Azure security, feel free to put it in the chat window and we'll address it at a later time. But that will be it for today. I hope you learned something useful. If you're yet to join the Meetup group, what are you waiting for? So make sure that you join the Meetup group. I'll put the link in the chat window, so you can click on that and join the Meetup group. So let me put that in the chat window. There you go. Okay, so make sure you join. Otherwise, see you next week. So next week we'll dive a little bit deeper in identity security, and then at some point we're going to switch over to look at to look at net infrastructure and network security, and then application security and data security in Azure. Thanks very much. See you next time. Have a lovely rest of the morning, afternoon, evening, wherever you're joining from.